Welcome to Signal Processing Laboratory. In this video we are going to see the ninth experiment, speech recognition using support vector machine. So the support vector machine is a supervised machine learning algorithm used for both classification and regression. Though we say regression problems as well, it's best suited for classification applications. So the main objective of SVM algorithm is to find a hyperplane in an n-dimensional space that distinctly classifies the data points. So the SVM algorithm just classify the problems here. So the dimension of hyperplanes depends upon the number of features. So we are the dimension of the hyperplane, so it will depend upon the number of features we are using. If the number of input features is 2, then hyperplane is just a line. If the number of input features is 3, then the hyperplane becomes 2-dimensional plane. So it becomes difficult to imagine when the number of features exceeds 3. So in this experiment, the speech recognition is implemented using SVM binary classifier with 92% F-score for classifying digits 1 and 2. So the algorithm uses binary classification using support vector machine. So for SVM binary classification algorithm, which is a machine learning algorithm, we got all the training samples to train so that it can recognize the voice for the digits 1 and 2. So one sample was used, the short-term energy was calculated, then in which a window of 320 samples was used. The energy in the frame was calculated and the window was shifted by 160 and so on. So after that, similarly consecutive training samples were used and the short-term energy was calculated. So after the short-term energy is obtained, here it is shown in the red curve in this graph. So the initial and ending points of the short-term energy were determined and the area between those points are determined, and the original signal was cropped out. As a result of the values in the signal are basically noise which are not required. So after cropping the required part in the image shown here, so the third plot represents the required part of the signal on which the future extraction using MFCC has to be done. So after obtaining the required part of the signal, the MFCC was calculated with 13 coefficient. So now we got, suppose 13 into 73 matrix of MFCC of one of the samples. So we transposed it as a number 73 here. Will be changing for different samples, but 13 coefficient of MFCC would remain constant here. The features such as mean, mode, variance, covariance, correlation coefficient, minimum, maximum, etc. Such 9 calculations were done, and these singular values are stored in a training set matrix. So such calculations were done similarly for all the rest of the training samples. The labels were arranged for that such that every respective training sample is, whether it is 1 or 2, are labeled accordingly as 1 or 2. So in this program we have already trained the support vector machine, so binary SVM, which we are going to use as a classifier here. So it is going to classify whether the speech signal is having the either one of the digit, that is 1 or 2, based on the energy of the signal. So let's execute the program. So let's execute the program. So the energy is calculated for the input audio signal. So this is the output for SVM. So that is SVM based voice recognition. So in the next video we will see the next experiment. Thank you.